So in 1986, at the inception of the Mark III Toyota Supra, the 7M-GTE and its counterpart, the 1JZ, which later came out in Japan, originally came with what was known as a batch fire fuel injection setup. Now, the 7M from Toyota was among one of the first motors to actually come with port fuel injection in an engine. It was very early on with any kind of electronic fuel injection. So back then they had port injection and mostly throttle body injection. And it was kind of the crossover point from a carburetor into multi-point fuel injection. Now in today's video, we're going to be breaking down how exactly the batch fire fuel injection operates in this 1987 Toyota Supra Turbo behind me on the 7M GTE, but also we're going to be upgrading the injectors in this car and swapping it over to a sequential setup utilizing these beautiful Fuel Injector Clinic 1300cc injectors. Now I know many of you might think that, oh my god, those injectors are total overkill for your setup, and to be honest, yes they are. However, I'm building the car to run on E85 and make roughly 500 to 600 horsepower, and I don't want the fueling to be the limit at that power level. So with that, we are going with a larger injector setup. Now 15 years ago, if you asked me if such a large fuel injector would hurt the drivability of this engine and this setup, I would say yes, absolutely, it probably would. However, it is 2025, fuel injection technology has come a very long way, and the precision of larger fuel injectors is not as big of a problem as it was years ago because they have gotten so much better, the technology has come so far, and you can literally run a 1300cc injector setup on a 6-cylinder and drive like a normal vehicle. Now, is the fuel economy going to be as precise as a smaller injector? Probably not. At the end of the day, you're going to have some wasted fuel regardless, and with a bigger injector, it's going to be a little bit more prevalent, but it's not going to be such a big problem such that it's going to hurt the drivability of the vehicle. Now, if you guys don't know, on this channel, I do a lot of, well, pretty much all of my own work, and that's everything from the mechanical to the tuning to the paint and body work. Neighbor's mowing his lawn, I apologize. All the way to this video and the editing and photoshopping, and yeah, I think you get the picture. Basically, I'm a one-man show here on this channel. I do everything myself from start to finish, so I have a good knowledge base of what goes in and what's required to get this thing set up. We're going to be going through the not only installation process, but also the computer setup in my ECU Master Classic to get this car set up from the traditional batch fire fuel injection setup to the sequential setup. So with that said, let's break down what you need to know about a batch fire fuel injection setup in this Supra. Now obviously on this car, it is a 6-cylinder. We have the 7M GTE turbocharged 3-liter. It has multi-port fuel injection. So there's one fuel injector on each runner of the intake manifold. So on modern fuel injected vehicles, the fuel injector will only fire once every combustion cycle of the engine. Now these are 4-stroke motors, so you have intake, compression, combustion, and exhaust. Now since it's batch fire fuel injection, you have 2 cylinders that are paired together when the fuel injectors fire. Basically, 2 cylinders will rise to the top dead center at the same time, and that is where they get the batch fire fuel injection pairs. So we have 1 and 6, 2 and 5, and 3 and 4. Now that's not necessarily the cylinder firing order, because with the cylinder firing order, you have 1, 5, 3, 6, 2, 4. I hope I'm making a little bit of sense. If this is helping you guys out in any kind of way to better understand it, do me a favor, drop a comment below, smash the like button for me. If you really appreciate this series, be sure to subscribe. So now that we got the basics of the batch fire fuel injection system out of the way, let's go into a little bit more detail on the workings of the 7M fuel injection in particular. Well, not just this car, other cars have similar things. From the 80s, early fuel injection setups had what was called low impedance injectors. And with low impedance injectors, they basically ohm out, I think, about 5 to 7 ohms, I want to say. If you guys enjoy this content, want to support the channel, want to learn more about building your own project car, do me a favor, head over to the web store, get yourself some merch, help you guys out, help out the channel. Also, don't forget to smash the subscribe button, hit the little like button for me. I greatly appreciate every single one of you. Let's get back into today's video. What you have to do here is actually delete this little guy right here. This is what's known as the resistor box. Any low impedance 80s fuel injection setup, they do still make low impedance injectors. I don't know why you would use them, but On these cars, we're gonna delete this, which is basically just going through this box right here, taking all of these power wires and crimping them together. That's literally it. And then we have to pull all of this part apart to get to the fuel rail, which is beneath that. So, let's get started. Which, by the way, I got these injectors courtesy of my boys over at Boost Lab. They may not have them up on their website, but they can get you injectors should you need any. And these are Mark III Supra specific injectors. 1300cc, it has the appropriate O-rings for the bottom end to fit right into the factory fuel rails and the factory OEM 7M intake manifold. Then later on, if you want to change them out, you swap out your intake manifold, you can just pull this. This is actually an adapter cap. You just pull the adapter cap off. Damn, those things are shiny. And then you put whatever O-ring you need for your new style intake manifold, and these will still work just fine. 1300cc's, these are going to be awesome. Will make all the power I need with the 85. They should max out at probably right around 700 horsepower. Probably won't ever make that much power on this car. Maybe I will. We'll see what happens when we get there. So in case you're wondering what this guy here is, this is actually for the boost gauge inside the car. Probably gonna have to paint this engine bay at some point because it's somebody obviously rattle canned over everything black apparently. One of these days, we're going to rebuild this harness. We're going to redo all of this. This igniter is not ultimately going to be here at the end because we'll probably end up switching it all over to a higher performance coil on plug setup. Mainly, I like the R35 coils because that's actually what I'm running on my 300ZX. So we'll probably end up upgrading the coil packs at some point. But for now, we're going to work with these and see what we got. I'm just gonna throw this out here. I'm gonna call you guys out a little bit because for maybe not 90%. Most of you that are watching this are like, oh yeah, I can do that. Until you get to this point right here, because it scares a lot of people. And to be honest, there's no reason to be scared. You just gotta do it. Oh no, the end of the world. It's not that bad. Because you know what? At the end of the day, it's all repairable. It's all just wires. It's all crimped together anyways. Notice how I said crimped together, not soldered together. Crimp them all together on one side. Right? Right. Shrink over top of it is any good. So the injector resistor box is now out of the way. It's one less thing in the engine bay. There's only about a million other things we gotta get through on this car. Now let's move on to the fun stuff. The intake manifold, the throttle body. Let's get started on all that. Okay, so I just took the throttle body and the ISC off. This is also known as the idle air control valve. And there's actually coolant lines that run through this, out of this, and then into the throttle body and out of the throttle body. Because I'm in a warmer climate, mainly Florida, we don't see freezing temperatures, and that's the only reason there's coolant lines running through these to keep them from freezing up in frozen, frigid temperatures. So with that said, I'm actually going to delete all the coolant lines, run through all this stuff, which pretty much entails either removing this red line here or this red line here and just looping it on the block, which run, because they both run under the intake manifold, so I'll tie them in together underneath the intake manifold. Not gonna be able to get you guys a good look at that, but I'll probably just pick one line or the other and just loop it to the other one. This car has so much stuff in it that is just unnecessary. Like, since this looks like a, I don't know, a purge solenoid or a solenoid of some sort. It's not needed. Got this one, which was also just chilling in here, not connected to anything. Probably also some sort of purge solenoid that's not needed. Okay, so to further clarify what I just did with the coolant line routing, basically you have your throttle body, and your ISC. And they sit on the back of the intake manifold, kind of like this, except you're looking down on it, right? I'm gonna show it to you like this, because you're standing on the passenger side of the car looking at this. This line here goes down to the back of the block right above the rear notch sensor, and this one goes towards the front of the motor, kind of right above the front, right in front of the front notch sensor. Basically, all I do is obviously remove this line, remove this line. We run one end of the hose from this side to the end of this side. Okay, so now that we are all up in here, right, we got everything cleared out of the way, we can clearly access the fuel rail here. I do just have to remove this one hose for my breather system. Other than that, we have full access now to the fuel rail and fuel injectors. So now, just make sure your fuel pressure system is depressurized if you haven't already, and obviously make sure your battery is disconnected. And then we're just gonna undo the fuel rail, pull it off, and we'll throw the new fuel injectors in. Should be able to slide right back on because it is pretty much a bolt-in thing with the new fuel rails. Then we will have to run new wiring because the electrical connectors are different because, well, these are no longer batch fire injected. They will be sequential injection, which means each injector needs its own output from the ECU. The vehicle supplies constant power to the injectors via relay. However, they are each grounded individually at the ECU via injector pins. So I gotta figure out which ones are already pinned to the ECU directly, cut those, bypass the other ones, and then we'll be good. Of course, we gotta lube up the O-rings on the new injectors. Lube it up. All right, so fuel injectors are in, fuel rail is in. I will have to find out another way to get the connectors on because it seems like the connectors actually have to go underneath the fuel rail. You can't even push the rail down all the way with the connectors pointing upward. So you're gonna have to point down, which goes straight into the fuel intake manifold, but it seems like the only way that they'll fit. I just wanna clarify some things on here really quick. And it has to do with the batch fire fuel injection. Earlier in this video, I did state that they fired in pairs, which they do. However, I got the pairing wrong. And I noticed that once I got into the wiring on this, it turns out cylinders 1 and 4, 2 and 6, and 3 and 5 are paired together. But aside from that, getting back into the car today, we are going to be building the harness for the injectors. I've decided that I'm going to just build a whole new harness for the injector wiring. We're going to run new grounds to the ECU, and then the power wires are going to get their 12 volt from the injector resistor, or rather where the resistor box was. I already went in there and crimped all the resistor wires together. However, I'm going to have to go back in there now and pretty much just redo that. Okay, so realistically, it's been probably about a week now since I've worked on the car, but throughout the week, I was working at my dinner table, literally my dinner table, building, well, I know my toolbox is kind of a mess because I've got Supra parts all over the place. Basically, we were building the injector harness. Now, what I decided to do was build a sub harness that I'm just gonna overlay on top of the factory harness. We have 6 injectors pinned up, ready to go. All I gotta do is finish off this side of it, which will go to the ECU. And all we gotta do is make the pins, pin them into the ECU, tell the ECU which pin goes to what injector, and it's good. Now, as for the basic breakdown of this harness that I made here, each connector is 2 wires, power and ground, 12 volt and ground. The power wires, being the red ones, all go out to this side over here, which we will tie into exactly where the injector resistor box was on the factory harness. So all of these red wires are gonna be clumped together like this and just spliced together. That's it. These here are essentially the grounds, being the black wires. Now, if you're like me and you pinned it all and you forgot which wire goes to which connector, you can just take your multimeter and then do a resistance test on which wire goes to which connector, essentially. So not too big of a deal that we don't have the wires. I actually wrote them down, but I forgot to mark which one was 1, 2, 3, 4, etc. So, but for now, let's get this thing laid in the car and get the power wires tied in. And then from there, we can lay everything in through the firewall and tie it all in at the ECU. And then we just gotta tell the ECU which injector goes to which cylinder. Okay, so I have my EFI resistor diagram right here. Looks like we've got yellow, black, and red wires going to the injectors, which are, so these three, which means this one here is the input 12-volt voltage, which we need to go to the new wires. So what I'm gonna do is I'm gonna splice this one back, move these off to the side, get rid of them, and we're gonna tie our new harness into this one wire right here. Okay, first order of business, let's make sure this thing fits in here as we want it to. Okay, so basically to save you guys the boredom of going through every single one of these, how I'm finding out, you know, oh, they're all black and red, black and red. If for any reason you get to where I am, and like me, you can't remember which one's which, pick one, set your multimeter to resistance, and go through and check all of the negative. If you don't check them on negative, just check both terminals. If you don't find one that beeps or comes up with some sort of reading on the resistance chart, then you really got to pull it all apart. Once it beeps, you know which connector it is, which pin it is, and then you just make sure you write it down at that point because, yeah, from then on, we're wrapping it up, we're tying it in. There we go. 2 down, the rest to go. Now we just cut the old wires out and call it a day. Woohoo! What I'm gonna do now is peel back the sheathing here, which is commonly known as Tech Flex wrap, and then we're just gonna tie it in right here. I'm just gonna chop all the wires back to there. Okay, so now everything is plugged in as far as the injectors go. The 12-volt power side is wired in. Now we gotta work on the ground side, also known as ECU pinouts, rather. Pretty much just gotta line up with whatever pins go to the appropriate injector. So, with that said, let's go ahead and work on the ECU side. All right, so we got the old welding rod. We're gonna poke it through with a little bit of tape, and hopefully it'll end up right where we want it. Okay, so we got the wiring inside the car now. All we gotta do is pin it into the appropriate spots on the connectors. And if memory serves me correct, these all go into the gray connector. So, I believe this is the side with the ECU, if I remember correct. Yes, because that has the map sensor going into it. Then, all we gotta do is pop this yellow thing out here, just like we have in the past. There we go. Now, all we do is find the pins that they need to go into and we push them right in. Okay, so I got my little cheat sheet here. This is literally a photo I took off of my computer. It has the pinouts of everything basically from the factory ECU, and it has the color coding on the ECU master adapter. I just go through here. We got injector 4 and 1 at 6 and 7, 5 and 2, 14, 15, and we got 22, 23 at 6 and number 3, if you must know. And then those all correlate to these green wires right here. So 6 and 7, 14, 15, and 22, 23. And then if you go on the here, you see 3 green wires going to 3 pairs of injectors for the batch fire fuel injection. So then what we're gonna do is we're just gonna cut these 3 wires, splice in these wires to those 3 that are corresponding with what that information says on there. And then we're gonna put pins on the other 3 to be pushed in right next to them. Okay guys, we are back. It has been a hell of a week. I have mostly finished the car. I still got a little bit of tuning and, well, tweaking to do on that, but I'm gonna go over the details today because I really had to take a break from recording because I ran into a bunch of issues. So this is not a part of the video you want to skip. Believe me, I'm gonna give you all the problems I have and that I went through and what eventually resolved it. I'm either A, a genius and a wizard, or B, the car is possessed. But either way, we got it all squared out. I've been fighting a cold all week. I've had a sore throat, so I got a cough drop in my mouth right now. We're going through this, guys. But for right now, I'm gonna be going over all the settings in the ECU Master software that is needed to switch over the Mark III Supra anyways, from batch fire fuel injection to sequential fuel injection. Believe me, I've learned a lot personally just in the making of this video. So let's get down to business, starting off with what is needed when you get a set of fuel injectors at the bare minimum. So when you swap out your stock injectors and you want to update it in the software, this is what you do. So what I ended up going with was the Fuel Injector Clinic. I believe they are 1200cc injectors. You can see right here, has all the flow data, they're matching. Now, what you really want is this right here, the drop-in tuning data. You scan the QR code, we go into here, and there's all sorts of different ones. There's HP tuners, Dodge stuff, M-Tron, Evo X. All you want is a universal data offset. What you want to do is you want to take all of this data from here. So we have different voltage based on whatever PSI, and stock base pressure is about 43.5. So you're going to take all of this data right here and put it right in to right there. I forgot one more thing. What you want to do is you go in here and you switch, come down and switch it to 1200. So for starters, what you do is you come over here, and honestly mine's at 1150 because, well, that's kind of the average matching data here is about 1150. I will say typically the larger the injector is, they have a harder time of opening at a lower voltage. So 8 volts, 7 volts, 1200 cc, especially like a 1700 cc injector, may not even open at that low of voltage. So it's not really as important. Now for the more complicated part. Okay, so initially it probably looks something like this, where it has the first 3 with numbers. I don't remember exactly what they are, and then the last 3 are disabled. So what we want here on the 7M is your standard inline 6 firing order. So with that, we have 1, 5, 3. You come through here, and when you do 6, 2, and 4. Originally, squirt twice per cycle is checked. We want to uncheck that. And the reason that is checked initially is because it is batch fire injection. What I've seen online is a lot of people like to switch this start ignition event to end of injection table. Now, to be honest, I tried this. I went back and forth with it quite a bit and I couldn't quite figure it out. However, I had good luck with just leaving it at start the ignition event and injection offset of 66 degrees. All right, and this is the current state that my car got to running in. Biggest problem I had was actually the cranking startup for the most part. Okay, so basically what you do is you come into engine cranking, engine start, and make sure this is all like, don't be flooding your cylinders. What I say is just cut it in half and start with that and then slowly bump in more fuel until it pops off. And then when it starts to pop off but it doesn't stay running, also, by the way, make sure your enrichments are not crazy. They should be at about 100. Anything in the operating temperature, and then also make sure anything below, like, obviously this is in Fahrenheit, and then like below 100 or something isn't like crazy high. This might actually be a little too high through here. I might end up cutting that, but we're gonna leave it as it is for now. I actually ran into a huge problem with the idle on mine because for some reason, well, the car had an insanely high idle. Like it wanted to stay at like 1500 RPM. And I don't know if that's because my idle air control valve was stuck or what the deal was, but it eventually started working and it brought the idle back down because I took everything back apart like 3 times trying to find a vacuum leak. I sprayed down the whole engine bay with brake clean trying to find a vacuum leak at a hose, couldn't find it. I eventually plugged in the idle air control valve, ran it for a little bit, and it eventually dropped back down to about 1,800 RPM, which is right where I want it for idle. With all that said, let's go ahead and start driving this thing because we got a lot to do today. I gotta drive the car this afternoon to a buddy's shop who's having like a grand opening deal type thing. And I wanna make sure everything's good and ready to go. So let's do a little bit of tuning. Let's get the car driving up the road. Hopefully it doesn't die on me. Obviously the harness turned out phenomenal. You can't even tell it's in there, really. Like, it's back there, believe it or not, but it's tucked underneath that. It runs along there. You see the pretty blue injectors. We're pretty much ready to go. So let's get this thing on the road. There we go. 1200 RPM idle, which I believe should be spot on. 1150. A little high. I think we can turn that down just a bit. All right, y'all, so we got the AC cooking in the thing once again. I had a little bit of leak. I think it might have been from just a Schrader valve, but I ended up replacing the lines up at the front near the radiator. Oh, there's a little puppy. And the AC compressor is making some serious noise. Dude, go home. What are you doing, buddy? Go home, you lost. I don't know whose fucking dog this is. I don't recognize this one. All right, guys, so we're out. We're gonna get some tuning in right now, finally. Hopefully my air fuel wideband stays intact, which it doesn't seem to be. Something seems really off with it. So the car's running pretty good right now under like light throttle and cruising and light acceleration. But I really don't want to do any wide open throttle stuff until I get this air fuel gauge figured out. My wideband's not reading correctly at all. It's stuck at 17.6 right now. Something's killing my wideband sensor, basically. And I haven't been able to figure out what it is. And now, my Super Sequential is making a lot of noise that it shouldn't. I can't seem to win, you guys. Man, there's just so much going on right now with this car. I'm a little bit of a predicament because I really want to get this done. I want to get some wide open throttle pulls, but it doesn't seem to be working right. At least we got the AC working pretty well. All right, so fuel injectors are plumbed in. We are currently running the motor on sequential fuel injection. In case you didn't know, well, it's hard to show you now because my wideband is all funky. All right, so as I was saying, you get a much more efficient fuel burn at idle, at light throttle conditions with the sequential fuel injection. So we're not burning quite as much fuel, but also it's a more precise fueling when you get to those higher load, higher boost situations, because you're injecting the fuel again when the engine needs it, not just sporadically in the cycle. Not to say it doesn't work. I mean, you could say the same thing about a carburetor, because essentially it's, at that point, it's firing the fuel, well, a carburetor's leaking fuel in, and the engine's just sucking in the fuel as it needs, based on the vacuum of the cylinder when the valve opens. So if you want to think about it like that, it's not that big of a difference. It doesn't really matter too much when you're at wide open throttle. It's more for light throttle conditions and idle, because if you remember at idle, I was having an issue with actually leaning out the cylinders, trying to hit that 14.7 stoichiometric. The engine only went into idle at like 11.5, 11.7 and lower. Anything leaner than about 13.5, it would want to stall out, ironically enough. We'll get there. It's all a work in progress. Like, it's kind of the name of the game, right? It's a project car. So a little bit of improvement over time. Next up, we got the fuel pump for the car. Really hesitant about it, but unfortunately it seems like I'm gonna have to drop the fuel tank for that. Not too excited about it, not too thrilled about it, but let's get this thing back home, check it over one more time, and let's close out this video for y'all. Well guys, I think that's gonna do it for this video. Next up is a fuel pump, and then we can start adding more power into the car. I might have to do something about the blow-off valve as well, but that's a work in progress and it'll take a little bit of diagnosing to figure out. Hope you all enjoyed this one. Take care. We'll see you next time.